So as Anjali and Lokik have very briefly explained what CNN actually is and what we do actually in CNN and how it's better than the topic we learned yesterday, which is nothing but multilayer perceptron, normal neural networks, and how it removes the complexity of that thing, and how can we manipulate images more enhancedly and more efficiently in the CNN. So we are going an inch closer to building a model now, a CNN convolution neural net model. So while building a model, we require multiple layers in that model actually. So there are multiple layers in that model. First of all comes the input layer, then the convolutional layer. It's like what a convolution neural network is. And then comes the pooling layer, then dropouts, fully connected layer. Some people call the fully connected layers as dense layers as well. It depends upon you, whatever you might want to call, you can call it. And then comes the output layer. So layers are everywhere in CNN. A model is basically comprised of multiple layers stacked on top of each other, and that is nothing but a sequential architecture it is. Now we will look the first layer in itself in the CNN model. So first layer is a what you say a input layer. So what do we look in the input layer? So like in a convolution neural network, we when we talk about convolution neural network, we mostly talk about classifying images basically, and so we start about that. So when we are classifying an image, we pass an input as an image only. So here we can see that image dimension of 28 by 28. Let's see for an example. Then that image will be converted into an array of, like, it will be passed as m number of images. So let's say we are training over only one image in a convolution neural network. Then that m will become 1, and the height and the width of that particular image will be 28 by 28. And the 3 you are seeing over here is the number of channels. As Anjali has what you say specified about the channels in RGB, what you say image. So red, green and blue. So these 3 channels are nothing but mentioned over here. So like this is how the shape of that image particularly looks like. And in the input layer, one thing one should actually focus upon is, like, when we train a CNN model over some image data, let's say it's of 28 by 28 for this example now, then it is what is expected that when you are trying to predict the class of that particular image, then you should also pass the image in the size in a dimension of 28 by 28. So that is the most important thing about input layers. Like I am also victim, like what I did, like I didn't pass an image of the same dimension on which I had trained the model, so it resulted an error. So like these things you should keep in mind. So that is all about input layer. Just basically it's an image we are passing as an input. Now the main crust of the convolution neural networks, which is nothing but a convolution layer. So if you don't understand convolution layer, it's like you want to eat but you don't know how to eat. So that's why please focus this briefly, and we will explain it very intuitively. So first of all, when talking about convolution layer, uh, when a person, a human, sees an image, what actually it does, like we are pre-trained and we have looked multiple images. So we identify the patterns, and let's say we say that the particular image is of dog or cat or human. But for a computer to identify that, it becomes tedious task. So what does it do? It looks the patterns in the images, and therefore it what we say makes some features to classify that image into a certain category, and that is done by the convolution layers, which detect the features. And also that's why the convolution layer is also known as a feature extractor layer, because in a certain image of, let's say, dog and cat, any image you can say, there can be multiple numerous features, and to identify those we need to what a computer or a machine learning model needs to identify the patterns or features, and that's why we call convolution layer as a feature extractor layer. And also some, what you say, fancy terminologies in the convolutional layer we will also discuss. Like there in this slide you can see there are 3 actual matrices you can see here. Like one is a source pixel, source image, then there is a convolution filter, and there is a output image for that after applying the convolution over that image. So I will specifically focus on the convolution filter here in this slide. So Some people call it convolution filter, some people call it kernel, some call it convolution kernel. You can name it anything. So what actually we do in convolution layer, that we create a, what you say, convolution filter and impose it over a certain part of that image, and we calculate the, what you say, particular matrix multiplication, like correspondingly, like this 3 will be multiplied with the -1 of that convolution filter, and so on. Means all the corresponding, what you say, numbers in that actual receptive field and a convolution filter will be multiplied and added together to get a result, and which will be passed on to a output layer of that specific convolution we just created now. So I just talked about one word, which is nothing but receptive field. So you might be wondering, what is the receptive field? So it's just a fancy word, but the, what is the concept is very clear, simple. Like the part of an image on which the convolution filter is imposed. Let's say is an image, and on this part I have imposed the, what you say, the convolution filter. So that exposed part to the filter becomes a receptive field. So that is as simple as that. And this, what you say, convolution filter will convolve all through the image so as to, what you say, find all the patterns in it. And that is convolution layer for you guys. And also we are humans, we need to relate something, any concept we learn to our day-to-day life. So a good correlation of this concept will be like in like when we are in like first second grade, like we used to draw something, and let's say some people are like me and don't know how to draw things very nicely. So what do they use? They use a tracing paper. So they takes and what is a pre-made drawing of some uh, artistic folk, and they will put the tracing paper over it, and then they will trace line by line, and they will just copy that into our what is a notebook. So here what you can visualize is like the notebook on from which they are copying the image is actually the input layer, input image we can see, and the tracing paper is like convolution filter or a kernel. And by tracing over it, we go pattern by pattern. We don't actually go like entire image one go, like in the tracing paper we go small precision patterns in that image and we draw them. So that is what the intuition of convolution layer is like. So let's move to the visualization part. So in this GIF, you can see how the convolution filter actually moves over the source image. So you can see this convolution filter, the actually the images of, what we say, three channels in there, as Anjali said, red, green and blue. So this filter moves over all these channels and calculates a value, adds a bias and produces output in the output layer of that particular convolution. So it's basically similar to what we had studied in the neural network, but in neural network what we had in mind, like a weight is nothing but a number, but here our actual kernel, the convolution filter, is nothing but a weight for that particular image we are trying to do. And we can also add biases on that to, what we say, to get a cumulative outcome for the convolutions. So that is a good representation. So after, so before actually deeply understanding what a convolution is, we need to just understand two important things, strides and padding. So first of all, we will focus on the strides part. So what actually strides are? It's very simple terminology. Like stride specifies by how much pixel the convolution filter will move over the input image. Like if we see over here, like the stride size is has the value of 2. So what do we interpret as, like this convolution filter we will go on the first of all, it will go to the top left of the input image, and then the stride is 2. So rather than moving by 1 pixel, it will move 2 pixels. So that is actually the stride thing is. And also we can also calculate the result matrix which will be produced eventually after the convolution ends. So there are simple formulas for that, and if we can plug the values in, we can actually what is it, find the result matrix dimensions. So let's try that. So first of all, NH is nothing but the height of the resultant matrix, and NW is nothing but the width of the resultant matrix. NH previous is nothing but the height of previous, input image. Okay, so let's plug in the values. So height of previous matrix is what? 6 minus the filter size. Filter size is what? 3. It's a 3 by 3 filter. And specifically, it's a vertical edge detection filter. After that, we add twice the padding, but we'll be covering padding in the next slide. So for this time being, padding is 0. So actual the numerator value becomes what you say 6 minus 3 equals to 3. So 3 divided by the stride size. So what is stride? Actually the size is 2. So 3 by 2, and we are taking a floor value for that. So 3 by 2 and its floor will eventually result into 1. So 1 plus 1 equal to 2. So the height of the resultant, what we say, is 2. And the width will be calculated as same, and thus we get a resultant matrix of 2 by 2 after applying a convolution filter of 3 by 3 over an image of 6 by 6. So bear with me, you will get this, and it's very easy. Like what is it? So later on, this is padding. So what is padding? Like in HTML or like when we do web development, we heard the padding. It's nothing but additional what is space we add over the existing images or like whatever it is. So same here, and the why we use padding is important actually. So after have what to say specifying certain stride value, we are actually, you may notice that the actual resultant matrix is somewhat smaller than the input matrix. So as to what we say, if we have to retain the size of the result matrix same as that of input, then we use actually padding, and that is the actual need of it. So here we have used a padding of 1. So all the horizontal and vertical fields are filled with a 0 padded. And then we same apply a filter over the image and we convolve over it. So what is convolving or convolution? When someone asks you what is convolving, what is convolution? So one filter is imposed over the input image, and then we move stride by stride over the input image, means the number of pixels are specified in that stride. And in that way, we convolve over the image and we get a convolution neural network output of that. Okay. So moving ahead, so like this will what you say give you the understanding. So let's say we have a vertical edge filter and this is the input. So how will it do? So first iteration will be like this. So it will be placed on the top left of the input pixels of that image, and then the multiplication will happen. So like 4 multiplied by 1, 9 multiplied by 0, and all those multiplications will be added and it will produce a result. So that is a convolution. And here the stride is 1, size of filter is 3 by 3, and we haven't used padding. We because let's say we don't want the resultant image to be as equal to the input size. We are okay with the 4 by 4 resultant rather than 6 by 6. So it's okay. And same here. So after this previous one, the stride, the filter will move to the second what is a stride. So like it will move by 1 stride, means 1 pixel it will move. So here it has shifted from 1 pixel and to the right, and then the same convolution operation has taken place and it's generated 6 as the outcome. So that is all what is a convolution, and convolution, what a convolution layer does. So that is why you need to understand this, and why you need to compute all the convolutions by yourself, because the person says so. And like keep in mind, like it's good to know what actually has been happening over the backend side. Like what we do, we do directly model dot add the layer, and we just what you say feel that all the computations are taken by the program itself and the libraries itself. But to get the feeling of it, just having a knowledge is crucial.